Okay, here goes. So when we say measures of central tendency, the things that we're talking about are the mean, the median, and the mode. There's one other that's sort of a measure of central tendency we'll talk about in a little bit, but the mean, median, and mode are the things that we call measures of central tendency. The mean is what you would commonly know as the average. It's add them up and divided by how many there are. And I'm going to give you a formula for the mean. And you might think, well, if it's just add them up and divide by how many there are, what do I need a formula for? I got it. And you might be right. But we're going to do some problem solving later on. And when we do that problem solving, I think this formula will come in handy for you. And that formula looks like this. X with a bar over the top, that's an abbreviation for the mean. And it's just the sum of the data points divided by the number of data points. Like I said, you're probably pretty comfortable with the idea of add them up and divide by how many there are, but later on, this formula will come in handy for us. Just a nice reminder of what the mean is, where it comes from. The sum of our data points divided by how many data points do we have. Up next, we have the median. And the median is just the middle number in a data set. There is one key thing that I want to mention about the median, though. It's not just the numbers given to us in whatever random order they were given to us, and it's the number in the middle. That wouldn't really mean anything. In order to find the median, first, we want to arrange the data values from lowest to highest. So once we have arranged our data points from the lowest to the highest, then we go find the middle number, and that is our median. And then finally, probably the simplest of all these is just the mode. And the mode is whatever is most common. So if we have a data set that is, to say, 3, 4, 4, 5, what would the mode be in that data set? Which data point appears most often? Great. Thank you, Summer, Nadine, Sandy, Katie. Awesome. You're exactly right. 4. It occurs more often than the others. The fact that it occurs 2 times doesn't matter. We don't report that. What we report is which data point occurs most often, and that would be the 4. You may be thinking, well, what happens if that's our data set? 3, 3, 4, 4, 5. Now, there isn't a most common data value. In fact, we have these 2 data points that occur more often than anything else. If there are 2 modes, if you will, then we would call this bimodal. And there would be 2 modes. The 3 and the 4 would both be considered the mode, and we would call this bimodal. And then the logical extension then is, all right, well, what if you throw a 5 on the end, and now you've got 3 and 4 and 5? Are we going to call that trimodal? No, we're not going to go that far. We're either going to have a mode or bimodal, or in a case like this, if it's more than 2, we're just going to say there is no mode. There is nothing in this data set that occurs more than anything else. Once we get past bimodal, we just say there's no mode. And no mode would be the case also if our data set were just 3, 4, 5. There's no data point that occurs more than the others. We would say that there's no mode. An important distinction that I want to make here, and it kind of came up last week when we talked about the firefighters wanting to be in a salary dispute, and are they going to use the mean, median, or the mode when they talk to the public? The truth of it is when we are talking in the language of statistics, any one of these can be called the average. When you're using statistical language, add them up and divide by how many there are. That's called the mean. The number in the middle is called the median, and the one that occurs the most is called the mode. The word average actually means typical in statistical language. And so any one of these could be called the average. and you wouldn't be incorrect. It's a little bit of a way to mislead, because you might say that, this one's the average because technically any one of these can be called average, because that just means what is typical. What's a number that represents this data set? And so add them up and divide by how many there are. We're going to call that the mean. I might slip up from time to time and use the word average there. If you do too, it's okay. The one in the middle is the median, and the one that occurs most often is the mode. Are there any questions about any of those sort of keywords, definitions, as far as working with measures of central tendency? All right, fantastic. So if we're given a data set and it's our job to find the mean, median, mode, and range, that's a new word for us for the following data set. Round the mean to the nearest hundredth. First, let's talk about what the range is. The range is very simply just the highest minus the lowest. So it's a very crude, very basic measure of how spread out the data set is. If the range is small, then there's not much of a difference between the highest and lowest. If the range is a bigger number, then there is a big difference between the highest and the lowest. And that's what the range will give us. All right, let's go through here and find the mean, median, mode, and range for this data set. All right, well, if I want to find the mean, I'm going to add them up and divide by how many there are. So that'll be 4 plus 6 plus 9 plus 3 plus 2 plus 3 plus 7. And we'll divide by how many there are, which is, let's see, 1, 2, 3, 4, 5, 6, 7 data points. So we'll divide by 7. Also, in checking that there are 7 data points, I'm going to make sure I wrote down all 7 so that I didn't skip any. 1, 2, 3, 4, 5, 6, 7. Okay. That doesn't guarantee that I wrote down the correct numbers, but at least I wrote down the correct number of numbers. And chances are I didn't make any of these up out of nowhere, so I feel pretty good about what I've got there. All right, let's go ahead and calculate the mean here then. We'll add those up. Oops. And we'll have, let's see, 4 plus 6 plus 9 plus 3 plus 2 plus 3 plus 7. That's 34 divided by 7 is 4.8571. And that keeps going. But I was told, as far as the mean is concerned, to round that to the nearest hundredth. So we'll find the hundredths place. We'll look one space to the right. That's 5 or bigger. So we'll round this up to 4.86. And that's our mean. Let me know if you have any questions on that before we go on to finding the median, mode, and range. Awesome. Okay, for the median, I need the number in the middle. So I look at this and I say, well, there's 3 over here, there's 3 over here, that one's in the middle, so the median is 3. Why is that wrong? Very good, Katie. Very good, Summer. Excellent. List them in order first. You're exactly right, Jackie. Before we find a median, we need to write this from lowest to highest. So let's see. That'll be 2. I've got 2 3s. I'm going to write both of those. A 4, 7. Oh, nope, I made a mistake there. A 6, and then a 7, and then a 9. So now we've got them written in order. Now we can look for the median. This is going to feel a little basic, because my guess is that each one of you can say, well, the one in the middle is this 4, so that's the median. And you're exactly right. But I do want to just point something out first about finding the median. In this data set, we have 7 data points, which is an odd number. What that means is because I have an odd number of data points, there will be one data point right in the middle. That is going to be our median. Now, there are 6 other data points. And because the median's right in the middle, half of these 6, or 3 of them, will be lower than the median, and half, 3 of them, will be higher than the median. So what my data set kind of looks like here is this. I'm going to have 3 data points lower than the median, 3 data points higher than the median, and the median sitting right there in the middle. It may feel like that's an awful lot of work to pick the one in the middle. You're not wrong. You just have to trust me on this, that this little setup right here in the green box will be valuable for us later on. In this particular case, I've got 3 below the median, 3 above the median, and my median is the 4 right there in the middle. Okay, we need the mode. Just sort of by visual inspection, and it's kind of a good thing. It's much easier to find the median after we've written these from least to greatest because they're all next to each other. Or excuse me, it's easier to find the mode once we've got them least to greatest because it's real easy at a quick glance to see what the mode would be. What's the mode here? Perfect, Nadine. The mode is 3. That's the only one that occurs more than once. That means it occurs the most. So the mode is 3. And then finally, we need the range. And again, having them written from least to greatest is really helpful when we go to find the range. And that's the highest, which is 9, minus the lowest, which is 2. And so the range is 7. How far is it from the lowest to the highest? So we were asked to find 4 things here: the mean, the median, the mode, and the range. The mean was 4.86, the median was 4, mode was 3, and the range was 7. And those are our measures of central tendency for this particular data set. Does anybody have questions on anything that we did there to find those values as far as the measures of central tendency is concerned? All right, very good. One of the questions that comes up sometimes is, okay, I got everything there, but one thing you did do was said when we've got an odd number of data points, there will be a number right in the middle to be the median. What happens if we have an even number of data points? And that's what we're going to look at here. Again, we're going to find the mean, median, mode, and range. And I don't know, I can find the mean without writing these from least to greatest, but I think it's not a bad idea just to sort of have an automatic reaction. As soon as I see this data set, the first thing I'm going to do is write them from least to greatest. Then I'll start worrying about finding the mean, median, mode, and range. And you can certainly work on these if you'd like. I'm going to go ahead and start with the mean. And the mean here is going to be add them up and divide by how many there are. And here, let's see, that's going to be 4 plus 8 plus 9 plus 12 is 33. Divided by 4 is 8.25. I was told to round to the nearest hundredth. Well, this already is. So I'm all done here. My mean is 8.25. If we do anything on this page that you're not sure why we did it, or it doesn't make sense, or it's confusing at all, you just make sure you ask. Up next, we'll find the median. That's going to be the number in the middle. Although now I have 4 data points, which is an even number. What that means is there is not going to be a number right in the middle. With my 4 data points, there's going to be 2 below the median and 2 above the median, but there's not going to be one sitting there in the middle for me. Here's how we handle a situation like that. What we do is we find the 2 numbers that are closest to the middle. So when I section this data set off and I have 2 lower than the median, 2 higher than the median, what I'm going to do is I'm going to find the 2 that are closest to the middle. And I'm going to find the mean of those 2 numbers. So the mean of those 2 numbers will be the median of my data set. If that feels a little odd, think of it this way. What we're looking for with the median is the number right in the middle. Well, I don't have a number right in the middle, but if I can find one that's halfway between these two, which is what I'm doing when I find the mean, then that's in the middle of this data set. And so my median here, I'm going to have to say, okay, well, then that's going to be 8 plus 9 over 2, which is 17 over 2, which is 8.5. And that's going to be the median of this data set. Couple of things that often come up, and you can absolutely bring them up if you want to, but something that comes up sometimes here is, well, I get going through this process to find the mean of those 2 numbers. Couldn't we just say what's halfway between 8 and 9? And you sure could. That's the same thing we're doing here when we find the mean of those 2 numbers is what's halfway between them. 8.5 is. And then another thing that comes up sometime is, well, wait a minute. Why is 8.5? How can 8.5 be the median of my data set? That's not one of my data points. And my response to you would be, well, we found the mean was 8.25, and that wasn't one of our data points, and that was okay. Same logic here. It's okay if the median's not one of our data points. It's a number that represents the middle of the data set. It's perfectly fine if it's not one of our data points. Looking for a mode here, everything only occurs once. So there's no mode. There's no data point that occurs more than any others. And then finally, the range. Well, let's see. The highest is 12. The lowest is 4. The difference between those is 8. So our range is 8. So for that data set, we have a mean of 8.25, a median of 8.5, no mode, and a range of 8. Let me know if anything we did to find those numbers raises any questions at all. All right, let's have you try one. So I want you to find the mean, median, mode, and range for that data set. If necessary, round the mean to the nearest hundredth. And I'm going to set up a poll for this. The poll is just going to ask you for the mean and the median. I want you to find the mode and the range, but we'll just talk about those. They won't be in the poll. So I'm going to set up a poll to ask you for the mean and median, but I want you to go ahead and find all 4 of these measures of central tendency. So go ahead and find the mean first, add them up and divide by how many there are. The median, the number in the middle, make sure you list them from lowest to highest first. The mode, the one that occurs most often, and the range, highest minus lowest. And then once you have the mean and the median, you can answer the poll. We'll go a little while longer on this one. All right, let's go another 20 seconds, and then we'll talk through this one together. All right, let's see how we did here. Okay, unanimous. That's outstanding. Not everybody was in on it, but hopefully everybody got it, even if they didn't respond. All right, so let's take a look and work through this one. So the first thing we're asked to find is the mean. So we'll go ahead and do that first. The mean here, oh, you know what? I went against what I said before. Automatic reaction, like Pavlov's dog, immediately write it from least to greatest. So we'll go 2, 3, 4, 4, 7, 8. Now we'll go find our mean. So that'll be 2 plus 3 plus 4 plus 4 plus 7 plus 8 divided by 6, since we have 6 data points. So add those up. 2 plus 3 plus 4 plus 4 plus 7 plus 8. That's 28 over 6. 4.66666 that repeats. We were told to round this to the nearest hundredth. So we'll find the hundreds place, look one space to the right, that's 5 or bigger. So we'll round this up to 4.67 for our mean. As we go through this, if you have any questions, let me know. The poll went great, so I feel pretty good about it. Here we have 6 data points. That's an even number. That means we will not have a number right in the middle to be our median, but that's okay. Half of these data points, 3 of them, will be lower than the median. Half, 3, will be higher than the median. And when we section off our data set like that, what we'll do is we'll find the 2 data points closest to the middle. They both happen to be 4s. You might write it down and say, well, I need the mean of those. 4 plus 4 over 2. That's 8 over 2. That's 4 to be my median. Or instead, you might just say, well, halfway between 4 and 4 is just 4. And so the median is 4. So as far as the poll was concerned, our mean was 4.67 and our median was 4. And that was a unanimous answer, so that's fantastic. The mode, as we look at this data set, the only thing that occurs more than once is the 4. So the mode's going to be 4. And then finally, the range. Well, the range is the highest minus the lowest. The highest is 8. Lowest is 2. So the range is 6. The poll went great. We didn't have the mode or the range in the poll. So let me know if you had any questions about either of those or anything else that we did there. Okay, outstanding. Something that you may not have seen before, and to be honest, something you might think, yeah, I guess I see why that could be valuable, but I don't know if it's for me, is called a stem and leaf plot. It's just a different way to organize a set of data. And it's a shorthand way of writing a data set down from least to greatest. And here's how a stem and leaf plot works. Basically, I want you to be aware that these exist, aware of how they work. It's not going to be a major focal point for us, but I do want you to be aware of them. A stem and leaf plot, when we've got a data set that looks like this, and I can kind of see at a quick glance here that, nothing's bigger than in the tens place. And so what I'm going to do is I'm going to create my stem over here with my tens digits. And as I look at my data, I see 30, 40, 50, and that's it. So in my stem, I'm going to use the digits from the tens place, 30, 40, 50. And so that's my stem. And now I'm going to put my leaves over here on the right. So when I see the data point 30, I'm going to put a 0 right here. And that 0 represents 30 because this is my tens digit and my ones digit. So that 0 represents 30. And then 42, I'm just going to put a 2 right here because that means 42. And then 37, I'm just going to put a 7 right there. And the shorthand is I don't have to write the entire number down. What I'm doing here is this 7 represents 37, and I know that because it has a 3 over there in the stem in that same row. And I'll just continue this all the way down my data set. Next is 35, 44, 58, 41, 55, and 30. Now I want to make sure I didn't miss any. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9 in my stem and leaf plot. If you're thinking, okay, I get it. It's a little bit of a shorthand, but I'm not seeing these from least to greatest. What we have right here is called an unrefined stem and leaf plot. If we want to finish this up and actually make a stem and leaf plot for this data set, we need to refine it. And what we do when we refine it is we put them from least to greatest. So I'm going to have the same stem with 3, 4, 5, but now I'm going to rewrite these numbers in the 30s. I'm going to rewrite those from least to greatest. So it's going to be 30, 30, 35, 37. And then in the 40s, I've got 41, 42, 44. And then the 50s, I have 55, 58. And now what I have over here is my refined stem and leaf plot. It's my entire data set, and it is written from least to greatest. I've got 30, 30, 35, 37, 41, 42, 44, 55, 58. A little bit of shorthand. Like I said, you might think, hey, that's pretty cool. You might think, yeah, I just write the actual numbers down. Totally fine either way. I want you to be aware of these. If you see one of these, I want you to understand how to read it. Do you have questions on what we did here to make this refined stem and leaf plot before I have you try one? Okay, here goes. There's a data set. Again, it's just tens digits. It could be if they were all in the hundreds, we could do it that way too, but we'll keep it simple just to get the idea across. What I want you to do is just take a few minutes and try to make a stem and leaf plot out of that data set and then refine your stem and leaf plot to have a finished product. I'll just give you a few minutes to do this and then we'll talk through it together.
All right, let's go another, I don't know, 30 seconds, and then we'll do it together. If you need more time, let me know. And if you have any questions as we go through it, absolutely let me know. Okay, here goes. So we'll start out by looking at our data set. I have 60s, 80s, 70s. That's it. So my stem is just going to have 6, 7, and 8 representing 60, 70, 80. Not every time are there going to be 3 in the stem, and not every time is it going to be in the tens digit in the stem, but just to get the idea across and keeping it relatively simple, now I'm going to write down my data points. I have 67, 85, 73, 63, 74, 84, 61, and 72. And I have 1, 2, 3, 4, 5, 6, 7, 8 data points, and that's how many I have. Now I want to refine this stem and leaf plot so that it goes from least to greatest. And in my 60s, that's 61, 63, 67, 72, 73, 74, and 84, 85. And here's my refined stem and leaf plot. Any questions on that? Any questions on how to read one of those? If I asked you, what does this number right here represent? What would you tell me? Excellent, Brianna versus Andy. Perfect. You're exactly right. I don't want you to say 3. I want you to say 73. Very good. Excellent. Okay. This also may feel a little simple, but you'll see why I mention it in just a minute. If we wanted to add up 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus 5, we don't really have to do it that way. Multiplication can be a shortcut for repeated addition. If we want to add the same number up over and over and over and over again, we could just multiply. Instead of adding 5 7 times, we could just multiply 7 times 5 and get 35, and that would be the same thing as adding all those up. Again, this may feel a little simplistic, but I promise there's a reason for it. The next thing we're going to look at involving data sets are frequency tables, and we're going to use repeated, instead of doing repeated addition, we're going to use multiplication as a shortcut. So here's a frequency table. It's a way to organize data when we have a whole lot of it, and a lot of the data points are the same as each other. And that's what we've got here. The number of students in classes at a school was counted with the following results. So imagine an assistant principal walking up and down the hallway of a school going, how many students are in this room? 15. How many students are in this room? 22. How many students are in this room? And so here's the data that they found out. First thing I want to do is make sure this frequency table makes sense. Over here on the left, we've got our data points, the number of students in classrooms. There were some classrooms with 15, some with 22, some with 28, some with 40. And then this frequency column, and this is sort of what makes this a frequency table. The frequency column tells us how many times that data point occurs in our data set. So what that means is there are 3 15s, there are 7 22s, there are 5 28s, and there are 2 40s. If we were going to write down the entire data set, it would be, well, there's 15, another 15, another 15, 1, 2, 3, 4. I've got to write 720. Okay, now I see the value of this frequency table. I don't want to write this entire data set down. I would much rather have it in this form of a frequency table. And so that's what we've got here. One key piece of this, one really important part is there aren't just 4 data points. Instead, we have 3 15s, 7 22s, 5 28s, and 2 40s. So the number of data points that we have is what we get when we add up those frequencies. So it'll be 3 plus 7 plus 5 plus 2. There are a total of 17 data points. Let me know if that doesn't make sense. We don't just have 4 data points here, we have 17. And that's going to be really important for us because when we go to find the mean and the median, also the mode and the range, but especially for mean and median, we're going to want to know how many data points there are. So the first thing we're going to do here is find the mean. And so the mean of this data set, well, I could do 15 plus 15 plus 15. But instead of that, I'm going to use repeated addition. If I want to add up all those 15s, instead of doing 15 plus 15 plus 15, I'm just going to do 3 times 15. Same thing with those 22s. I have 7 22s. I have 5 28s. And I have 2 40s. And then I need to divide that by, be really careful here. It's important that we have 17 data points. We're going to divide by 17. If anything in there doesn't make sense and it's not clear, please tell me, ask your question. If you have it, somebody else probably does too. Okay. Now let's go ahead and finish this off and find our mean here. 3 times 15 will be 45. 7 times 22 is 154. 5 times 28 is 140. 2 times 40 is 80. We need to add all that up and divide by 17. All right, well, 45 plus 154 plus 140 plus 80 is 419 over 17. We'll divide that. 24.6470. And we're supposed to round that to the nearest hundred. So we'll find the hundreds place, which is this 4 right here with 1 space to the right, 5 or bigger, round that up. 24.65 is the mean. So what's the mean number of students per classroom? 24.65. Let me know if you have any questions about what we did there to find the mean. The thing that's new is, yes, we only have 4 different data points, but we have a total of 17 data points. This frequency is really important, and we use that when we go to calculate the mean. Okay, we'll save the median for last here. The mode, really nice about the mode in a frequency table. What's the mode here? It's really easy to spot the mode in a frequency table. What is the mode for this one? Don't overthink it, trust your instinct. Very good, Summer Nadine, you're exactly right. Well, the mode is the one that occurs the most, and there's 7 of these. That's more than anything else. So the data point that occurs the most is the 22. So the mode is 22. Perfect. The range, okay, range is just highest minus lowest. So my highest data point is 40, and my lowest data point is 15. So 40 minus 15 is 25. And what that means here is the spread between the smallest classroom and the biggest classroom is 25 students. That's the range between the smallest number of students and the highest number of students. The mode being 22. The most common number of students in a classroom is 22. Okay, I saved the median for last. And of all the things we do with measures of central tendency, I think finding the median in a frequency table is probably the most challenging. So far, it doesn't seem like we're having any issues at all. Mean, median, mode, and range for a data set, odd number of data points, even number of data points, no problem. Okay, well now we're finding the median in a frequency table. I need the number in the middle. So let's go back to sort of our basics here with finding a median. I have 17 data points. That's an odd number. That means there will be one number right in the middle to be my median. And then there will be 16 other data points. Of those 16 data points, 8 will be lower than the median, 8 will be higher than the median. So what my data set kind of looks like here is 8 data points lower than the median, a median right in the middle, and 8 data points higher than the median. That's how my 17 data points break down. Let me know if you have any questions about that idea before we go forward. Awesome. So here's how I'm going to find the median in my frequency table. I'm going to start counting from the lowest data point down here. And I'm going to count data point number 1, number 2, number 3, 4, 5, 6, 7, 8. And then the 9th data point that I get to, that's going to be my median. When I count from lowest to highest, the 9th one I get to is going to be the median. Because the first 8 are these. And then the next one, the 9th one, that's going to be my median. So let's count them up. All right, well, let's see. I have 3 of these, so that's data points number 1, 2, and 3. Then I have 7 of these, so that's going to be data points 4, 5, 6, 7, 8, 9, 10. I could keep going. This would be 11, 12, 13, 14, 15, and this would be 16 and 17. But the only one I cared about, the only one I wanted to zero in on was the 9th data point. And the 9th data point is one of these 22s. And so the median of my data set here is 22. If I were to list all 17 out from lowest to highest, I could see that there was a 22 right in the middle. I could also do it this way, much more efficient. 17 data points is an odd number, so there's one in the middle. Of the 16 other data points, 8 are below the median, 8 are above. So if I just count lowest to highest, the first 8 are these 8 down here. The 9th one that I get to is going to be the median, and in this case, that was a 22. Let me know if you have any questions about how we did that. Because like I said, I think finding the median from a frequency table is probably the one thing that might trip you up a little bit when working with measures of central tendency. All right, let's practice. What I want you to do is using this frequency table that shows the number of animals at different shelters are as follows. So we have the number of animals and we have their frequency. I want you to find the mean to the nearest whole number, the median, the mode, and range for that frequency table, the data in that frequency table. I'll set up a poll for this, and like before, the poll will just be mean and median, but I do want you to find the mode and range also so that we can talk about those two. Okay, I'll set up the poll for it. So keep in mind here, we're finding the mean, add them up and divide by how many there are. Make sure you take the frequency into account when you do that. The median, which is the middle number, again, make sure you know how many data points there are when you go to find the median. And then the mode that occurs the most, and the range, which is just highest minus lowest. I'll give you more time on this. We don't need to be in a hurry. And just so you know, this is definitely the type of question you can expect to see either in the book on homework or on the worksheet or um, on a quiz or on an exam. So definitely a good one to practice because if you can do this, then you know you can do those. That happens sometimes, Summer. Don't worry about it. It's okay. There's no stakes here. You know what I mean? This is just to. I appreciate you telling me though, because this is information for you, but it's also information for me. Like when we work through it together, you can see like, oh yeah, I did it right. I just picked the wrong button, or even oh, I can see what my mistake was. Okay, I've got this covered. On my side, all I get is your responses. So the only thing I know is how many people got it right and how many people didn't. And so if you say, wait a minute, I think I clicked the wrong button, that's that's good information for me because it lets me know that somebody who it shows up as getting it wrong may have gotten it right, which is, that's helpful for me. All right, let's go say another 30 seconds on this. And if you need more time, it's okay. Just let me know. All right, let's see how this one went. Not unanimous, but close, and it could be just a wrong pick. This one could have been unanimous also. All right, let's take a look at this one together. So we're going to need to find the mean, the median, the mode, and the range. If we're going to do that, it's going to be really important for us to know how many data points we really do have, and that's 5 and 4 is 9, 10, 11 data points. With that in mind, we can go ahead and find the mean. And the mean here, let's see, that's going to be, all right, well, I have 5 20s, so I'll do 5 times 20. I have 4 50s, so we'll do 4 times 50. We have 1 100, and we have 1 900. And we need to divide that by 11 because we have 11 data points. Be careful. There's a little bit. Oh, great. Very good, Summer. So we're unanimous there. So we don't want to divide by 4 because we see these 4 numbers over here. It's a really easy mistake to make, but just remember that frequency table is important. It matters. It means something. It tells us how many data points we have, and we have 11 of them. All right. So to find our mean, 5 times 20 is 100. 4 times 50 is 200. 1 times 100. 1 times 900, all divided by 11. And now I need to add those together. Let's see. 100 plus 200 plus 100 plus 900 is 1,300 divided by 11. And I get 118.18181818. This time, I wasn't told to round to the nearest hundredth or even the nearest tenth. This time I was told to round to the nearest whole number, which is going to be the ones place. We don't do whole number very often, but here, I don't know, it kind of makes sense. We're talking about how many animals are in a shelter, so a whole number seems like a perfectly reasonable way to round this off. And we'll look to the right, that's 4 or lower, so we'll round this down and have our mean be 118 to the nearest whole number. Okay, save the median for last. The mode. Mode's nice and easy in a frequency table. The largest frequency is here with this 5, and that goes with the data point of 20. So the data point that occurs the most is the 20. So the mode is just 20. So we have a mean of 118. We have a mode of 20. We need a range. Let's see, the range is going to be 900 minus 20. Wow, that's a big range. That's what, 880? Yeah, a goofy number like that. I'm going to just make sure with my calculator. Sure enough, the range is 880. And then last but not least, we need the median here. For the median, we have 11 data points. That's an odd number. So I will have one data point right in the middle, and I'll have 10 other data points. Of those 10, 5 will be lower than the median, and 5 will be higher than the median. And so when I go to find my median, what I'm going to do is I'm going to start counting down here at the lowest. And then data points 1 through 5 will be here, and it's the 6th data point that I get to. That's going to be my median. All right, well, let's see here then. Data points 1, 2, 3, 4, and 5, and then 4 of these. So data point 6, 7, 8, 9. And if I wanted to do the rest of them, data point 10, data point 11, but the only one I really cared about here was the 6th data point. Here it is. That means it is a 50. And so the median of this data set is 50. As far as the poll goes, our mean was 118 and our median was 50. Let me know if you have any questions about finding those 4 different measures of central tendency from a frequency table. Okay, there is something I want to mention here. We talked last time about the idea that if you were a firefighter and you wanted to lobby for salary, you're going to use the smallest possible number you can when you talk to the public about what your salaries are, because you want to give a strong impression that you're in need of a raise. There's nothing wrong with that. All the data is true. Which number you decide to report is up to you. Here in this case, we're talking about these animals at different shelters. Now, forgetting trying to make a case to the public about anything, strictly mathematically. And when we look at, say, the mean, which is 118, the mode, which is 20, and the median, which is 50. The range is more about the spread. It's not really what's typical for this data set. But, we have 5 shelters that have 20 animals. We have 4 shelters that have 50 animals. We have 1 shelter that has 100 and 1 shelter that has 900. It's a pretty good chance that one of these 3 measures of central tendency here is the best reflection of this data set. And you don't necessarily have to agree, and I don't really want to make this an opinion question for right now. I really want to steer you in a certain direction and sort of explain why we hear statistics in certain ways sometimes. One thing that can happen here, as you look at these numbers, there's a little bit of one of these is not like the others. 900 down here. I mean, these shelters that we're looking at, they have 20, they have 50, 100's kind of big. 900, what the heck is that doing here? That's kind of a goofy number for this data set. This is the kind of thing we might call an outlier because it doesn't really fit with the rest of this data set. And what happens is when we have outliers like that, those outliers have an impact on the mean. When I've got these 520s, these 450s, this 100, those are all kind of in the same ballpark. And then I drop this 900 on here, and what it does is it blows up my mean. This mean of 118, I would say that is not a good representation of this data set because there's only one data point in here that has more than 118 animals. If I were to say your typical shelter has 118 animals, I don't think that's right. That doesn't feel like a good indicator of what's going on here with these numbers. And what's happened is this outlier of 900 blew this up and made it a lot bigger than a number that really represents the data set. You might be able to make a case for the mode here in saying, well, that is the most common that there's 20. But again, I don't know that I would say that's typical of what's going on here because we do have quite a few shelters that have 50 and we have 100 and we have one that's really big and kind of crazy. But I don't know that I would say your typical animal shelter has 20 animals in it. I think for here, in this case, and honestly, in a lot of cases, the median is the best representation of the data set. A nice thing about the median is that it is stable. That median wouldn't change. If this number were 9,000, the median would still be exactly the same. The mean would blow up, but the median would still be the same. It would still be that 50. It wouldn't matter. This is why when you talk about housing prices in a certain area, the median is the number that's often reported. And it's because if you drive down a street and you got a house that's 400,000 and a 500,000 and another 400,000 or 450,000, and at the end of the street you've got one that's worth $9 million. Well, if you said the mean house price on that street is $3 million, that's not really representative of what's going on there. The outlier of that $9 million house blew things up. Median, though, would be very stable. It's going to be the one in the middle. Doesn't matter if you have one goofy high number or one goofy low number in there. The median is going to be very stable. And so that's why you'll often see the median used to represent salaries or house prices or things like that, is because it's very stable and it's not impacted by outliers the way that the mean certainly is. Hopefully that makes sense. If not, you can ask me. Basically for this one, I was going to say, okay, which one do you think is the best choice? But you can make a legitimate case for any of these, but I do think the median has the strongest case, and it's because it's not impacted by the outlier. All right. That's what I wanted to talk about as far as measures of central tendency